Hello everyone, my name is Vahid Bazzaz. I'm doing Master of Civil Engineering in University of Wollongong, and based on the authorities, the broad topic for civil engineer student was the soil improvement with scrap tires, and my specification in this presentation is analyzing of using tire chrome and woven geotextile in roadbed structures. But first of all, I want to talk about the soil weaknesses in roadbed structures. As you know, for soft soil structures, maybe we can see inadequate shear strength and also the long-term deformation which could be happen during the construction and after the construction. For example, after 4 years or after 20 years, even 20 years, we can see the permanent deformation in the structure that would be cause for the failure. And also the enforcement to build the thick layers. This matter comes from the natural feature of the soil, which is the plastic material. So it needs to have the enough thickness to tolerate all the forces which coming from the other axes. And also this thickness definitely can impact on the cost and the time of the project. So typically, soil structure projects are totally inefficient if we don't use any treatment for them. So the first question would be, what is the soil stabilization material? So if I want to summarize it in one sentence, is the excluded material would be involved with the soil and optimize the performance of the soil in this structure. We have vast number of stabilization material for the soil, but as I want to mention in this presentation and what was in my report, I want to mention about 4 different types of soil materials, which is lime, bitumen, scrap tire, and geotextile. And you can see in these pictures for lime, bitumen, geotextile, and also scrap tire at the end. So why soil structures are very important? The reason is because of the being infrastructure. So usually soil structures are kind of infrastructure projects. So it costs 100 people's life if the failure happen in the project. Also, it costs millions of dollars to resolve the failure problem, and make the new project on that area. And also the failed embankment in Turkey was the very tangible example. It happened in 1998. It cost more than $2 million to resolve the failure problem, and also it takes 1 year time to resolve the problem. And the current soil stabilization, which I mentioned at the very last slides, was lime and bitumen. With both of them, they have historically used in soil treatment, and both of them they increase and improve the compressive strength and shear strength in the soil. They also decrease the thickness of the structure, and they are time efficient. They also have some drawbacks that's not included in this presentation, because our concentration of the scrap tire stabilization materials. And actually using scrap tire materials can actually shoot both targets. The first of all is resolving the environmental problem that stockpiling the scrap tires made very big environmental issues in last decades. And also we can reuse in this material in civil project structures. Also, for those scrap tires they use in the civil projects, they have been categorized in 4 different groups based on the shape and the sizes. So it has from the biggest one is the shredded tire chips, granite tire, and tire powder, which comes getting the smaller respectively, as you can see in these pictures as well. And also based on the previous researches about the performance of the scrap tire in soil improvement, I can mention regarding to the optimized proportion of the scrap tire content in the soil. It's not over than 40%. In maximum 40% content, we can see the increasing shear stress and eventually the increasing the bearing capacity of the soil, also deducting the total unit weight of the structure and decreasing the displacement during the earthquake, and increasing the friction angle of the soil. However, it has some drawbacks as well. The problem is because of the restriction in proportion content of the scrap tire, we cannot access to the this feature, which is reducing the unit weight appropriately. So for cover this problem, I want to mention about the type of geotextile as a secondary stabilization material in our design. So we have two different types, woven and non-woven. Based on the researchers, woven geotextile has more appropriate efficiency in soil treatment. As you can see in this two picture, this one is geocell, which is non-woven, and here is the woven geotextile material. And performance of the woven geotextile in soil improvement is increasing up to 130% performance compared to untreated soil, and usually executed in 3 layers and enhancing the peak shear stress of the soil. Also, it effect on the compressive strain, and it decreases the thickness of the soil. That's actually we are looking for. And it has its own limitation as well. The limitation of the woven geotextile in the soil is the friction reaction between different type of material in the soil, which is for geotextile or geocells, woven geotextile and the soil. So it has a limitation in varied temperature during the structural lifetime, and that's why geotextile could not use as a primary, so it would be our secondary material. So our design is about our innovative things is about tire chrome and woven tiles combined together. So we can see it could be cover each limitations, and we can see in these two figures, we can see the top one for tire chrome and the bottom one for woven geotextile. And these two figures represent information about the peak shear strength with treated soil in tire chrome and geotextile. And you can see the peak shear stress in tire chrome is going up to the 500 kPa, and for woven is going to the 200. And our design is combining these two information from the previous studies to combine in 4 different samples for our experiment. You can see in the untreated soil, treated soil, geotextile, treated soil, and mix of geotextile and the treated and tire together. So based on this information, we can see here for our 4th sample, which is our own sample, we made it by ourselves. We can see the picture says it exceeds to 600 kPa, and for conclusion, I can mention to what we got from this design. We are going for resolving the environmental issues which caused from stockpiling scrap tires and we can use it in the civil structures projects. And also, we mentioned about the strength and weakness of each treatment materials, the foil, tire chrome, and woven geotextile. And at the end, we optimize the optimized performance of mixing material together that acquired by this experiment. Thank you very much.